stream. Today we have very important procedure that we have here, replacing what we refer to as a double MCB or a double pole circuit breaker. Top bosses, what is very important here is to assure you that indeed this circuit is on, because if I may use this non-contact tester, things are live here just the same way we are live on this stream. This is another important thing that we need, because we require a stool just in case someone is receiving an electric shock, will be pushed away. A wooden stool is very important in these procedures, because in case, we are saying in case, but we will be very, very cautious, my top bosses. This is an non-contact tester, all right, and we have to use it so that we actually assure that everything is right here in terms of power. Right, my top boss, what is the correct name that you refer to it, and what brands do you trust? All right, is it Clean Tools? Now when we check on these, we can tell that indeed there is power. But you may ask, John, why are you replacing this important device here while it is on? Now, as you know, we are always focused on our customers, assuming that a customer has called you for this service. And at the meter box or the meter board where there are several customers connected, and you as the electrician cannot be granted access to it. But at the customers, this is the issue. How do you go about it? We'll be talking about that safety precautions matter, because safety again comes first. But the question or the elephant in the room is this: why replace this device here? What led to you replacing it? Another thing that we'll be talking about is, my top boss, the test that we'll carry out. Now, we noticed that the customer said that they experience dim lights. Another thing, there are times when machines or heavy appliances are switched on in the home, there is a problem because the lights flicker or the lights go dim. Now, if it would affect only one circuit, probably it could have been these MCPs. But the issue here is, if one circuit is activated, say a washing machine, say an electric cooker, which draws heavy current from now our source here or our box here. Of course, we understand that the source is the transformer, but for our case, we refer to it as the source. Why are lights flickering? Why is it not affecting one circuit? Definitely, we suspect this is the issue. But before we get in there and use our digital multimeter, which is this one here, to test for continuity, to test for visible signs on this double pole MCB, we will definitely be able to switch it off. Very, very important procedure. We have switched it off before we can access this cover. Remove the cover and then start by checking for any visible issues. We are at our customer's house and we want to know, is this setup here the problem, before we can go to other areas, because we suspect that. I talk most, let's do it. Now, there is something that I've also discovered in this customer, that there is a smell, something that is burning. So probably a plastic. You know, you have to be very good at sniffing. Sniff. So if there is some smell here, you know that there is a problem. Another thing that we've been talking about is a spark or a sound that comes from these devices or electrical fixtures that will tell you that indeed there is arcing or there is an issue. My top boss today, as usual, I'm privileged to have the company of the one and only top boss Margaret, who will be taking us through this procedure. Remember, very, very important that this circuit is on. How do you operate, or how do you replace devices that are live, that are on? We shall be talking about that, my top bosses, just to confirm that indeed this circuit is still on. Even if we have switched it off, there are power lines that come here. And so we will be talking about that, my top boss, even though we have switched it off, but we want to be very cautious about it. Even if there is a power outage, for instance, right now it could be a power outage, we need to be very cautious. Now it is time for us to access the inside of this consumer unit. Margaret, you would like to take us through by first greeting our top bosses and then go ahead. Karibu sana. Good afternoon, dear. That is from Abu Al. Karibu sana, Abu. Yes, Margaret, how are you today?
I'm fine.
Ready for this stream?
Yeah, very ready.
Top bosses, what do you think about our top boss, Margaret? Show her love by liking the stream. We really appreciate. All right,
Yeah.
Margaret, greet us.
Oh, hello guys.
Hello too.
Yeah.
Are you ready for this?
We are very ready.
All right. So the first procedure is access the consumer by simply removing the cover, and then we continue from there. Yeah. In this case, safety is very, very important, and we can see that our top boss is taking a lot of precautions. We have a screwdriver which is insulated,
Yes.
and that is very, very important, especially for a
Sorry.
consumer unit. Is okay. Sorry about that. Now removing the cover. Now our customer's consumer unit doesn't look good. Doesn't look good. The customer is not here, so we can badmouth them. But it is important for us to always um, have some manners. All right. Yes. So now with that, we want to also confirm with the non-contact tester because the double pole MCB, which one is it, Margaret?
This one.
So that is the one that switches power to the rest of the MCBs, right?
Yes.
Awesome.
Oh,
So power is going through.
very high.
Yes. Now, what that indicates is definitely the flow of current. So we have to be very cautious. Now, using the contact tester,
Yes.
at this point we have to test, is the live on the black cable or is it on the red cable, and which cable test it. So use the other hand.
This one.
Yes. Touch on the above part, place it on the terminals right there. So on the neutral, do we have any light on the tester?
Yes.
On the live, right? On the red.
Yes, on the road.
On the red. But on the black,
No.
we don't have, right?
Yeah.
So now for that case, what we need to do is to first of all, because it is off, can you test on the part below the MCB
This one.
that we are replacing? Yes. Anything?
No.
And on the other one?
Nothing.
Nothing. Awesome. Now, for this case, what we need to do, Margaret,
Yes.
is to start isolating what doesn't have power. So on the lower part, because we will definitely require to replace it,
Yes.
we start by that. So we remove that. And what you can see is the neutral there feeding the common or the other neutral. So we start by that and carefully ensuring that you remove it. Yeah. So top bosses, if you are getting value from our today's stream, kindly smash the like button. And also if you have any contribution, let us know. We'll appreciate on the chats you responding or asking about anything. Now, after removing that, we want to make sure that it is indeed safe by simply isolating it from there. And the best thing to reduce a lot of contacts is to simply tape it using an insulation tape. We can tape it because we will still remove the insulation from it, we can use any color. And my top boss, which color do you have?
Red.
Red. Awesome. Now that we are the only one operating on this consumer unit at the moment and no one is here, we are free to ensure that we go ahead and strip it. So straightening it is important, and ensure that you still hold it so that it does not slide and get to the live. Before you tape it, can you assure us that it doesn't have any current? Because actually it is on the, you can use the non-contact, it is actually going to the loads. No, nothing. Awesome, awesome.
This one.
Yeah, even that one, nothing. Incredible. So we go ahead and tape it. But someone would ask, why tape it yet it is not the one carrying current? The reason is, in case the other one at the point where it is removed slides and gets in contact with this, it might affect the circuit. So we don't want that scenario. Right?
Yep.
Good job, Margaret. And you can also fold it to look downwards, stretch it downwards like that. All right. Awesome. The next procedure is to isolate the incoming neutral.
Okay.
Yeah.
The way I'm tall.
You're very tall, right? You're blessed with height. Do you require some stool to step on?
No.
Oh, you're good.
Okay, I'm good.
Awesome. I love your attitude. Always positive.
Yeah.
Top bosses share a lot of love for our top boss, Margaret. She's been doing the most.
I might need this.
Good. All right. You want to step on it? That one will.
No.
You want
Angles.
to move right there.
Yeah.
Okay. Good job. Still okay. Ama you need a stool. I go bring it.
I need a hand.
You need a hand there.
Yeah.
All right. I will. So, okay, we just adjust our camera here. So my top boss is what Margaret is actually doing is ensuring that she isolates incoming neutral. Remember, it is not connected to the load, so isolating it will have no harm. So that is what we are doing, isolating the neutral, which is this one here. Margaret, you are still here with us?
Yes.
So have you unscrewed only one? I hope you have unscrewed the neutral only.
Yeah.
Not the face. All right.
No.
Now, having unscrewed it, can we remove it? Completely unscrewed it. All right. So let me just help Margaret with that. Okay. So what we do is to simply unscrew it. So we have to be very, very careful so that it doesn't get in contact with the line. And at the same time, we need to tape it as well so that if it slides, it does not get in contact with the main line that brings in power, right? Like that. So having isolated that, and our earthing is on the earth by this side, and of course the neutral is isolated, and then the neutral going to the neutral connection is also isolated. We also have this connection right here. So we want to make sure that we unscrew all of that. And remember, my top boss, we had indicated that we were suspecting there is an issue with this double pole. So that is why we are replacing it. One of the important tests that you need to test right there is the continuity. So the continuity between the neutral input and the output when it is on, right, and when it is off. So at the off position, we want to test for continuity, which is open, meaning that current cannot flow even if we connect it back. All right. And also to ensure that we have our digital multimeter inclined somewhere, you can simply do that. I don't know whether it is visible for our top bosses.
Yes.
And so if we do that, that is continuity. If you can hear the beep, can you hear the beep, my top boss? Let me know in the comment section whether you can hear my beep. Right. Now, testing for continuity, that simply indicates that there is a continuity, meaning that the wire is not broken or the circuit is continuing, not broken. If you get an infinity or a one, it means that there is no contact between that. That is just like measuring nothing, or the gap, the air gap, which has a lot of continuity. That is why it gives us a one or infinity. So between the output and the input at the point where the MCB, the double pole MCB is switched off, we get a 1, meaning it is not allowing current to flow. Another thing is on the neutral, and I mean on the other output and the input of the neutral as well as the line, we get a 1. All right. What if we switch the circuit back on after isolation and then ensuring that everything else is actually off? All right. And then test for continuity, test for the integrity of this MCB. So still on the continuity, on the line, we discover that it is okay. On the neutral, we discover that it is loose. There is an issue right there. Unless we really push it harder, we can tell that it is not really responding, because I have placed the probes in contact with the terminals on both the incoming and the outgoing. And this misbehavior is coming from the neutral side. And that is why we suspected that indeed this double pole MCB was having a problem, and indeed it is right. Top bosses, what do you think about that? If the neutral has an issue and the line is okay, do you think that can be a contributing factor to that problem, right? And apart from testing that, another issue that I would like to highlight is that whenever you carry out the test and you find that everything seems to be okay when no load is connected, then you need to go ahead and test for the voltage output at the point where all the loads are already connected. Assuming there's a washing machine, assuming there's of course, the lighting circuit is already connected, the sockets and all that. Ensure that everything in that house is powered on, and then come and perform another important test here, which is referred to as AC output, my top bosses. AC output, and you have to place it at 720. I wish Margaret can bring the camera closer so that you can clearly see these digits here. Yes, Margaret is doing the most, and we are very grateful for her. So are these figures here visible? Mm. Just lean it forward like that. The back leg, which is yeah. So at that point, we have the 750. So we expect 240 volts or 230 volts. So we place it at that. You cannot place at 200 and you cannot place at 20 because you expect higher values, right?
Yeah.
So we place it at 750 so that we cannot damage our multimeter. Incredible. Now, using our probes and considering that it is on, we want to make sure that we test the voltage. But remember, we had isolated the neutral. So the next procedure is to simply turn it off like that and then connect the neutral back. I know I've gone the other route, but I just remember that actually we needed to test for that voltage, but we cannot test for the voltage if we don't have the neutral, isn't it, Margaret?
Yeah.
Now, what we need to do is to return the neutral carefully back, making sure that we don't short circuit it very slowly. Because if there is a spark, then it means that we will have issues. Again, for such scenarios whereby you're operating a live circuit, you need to be very careful, because if there is a short circuit here, remember at the meter board, we have a DP-MCB such as this one. And if there is a short circuit here in the event that you are carrying out the repairs, it means that it will trip the double pole that is down there, meaning it will shut electricity supply or current supply to the house. So even if you replace that MCB and the double pole MCB, and the other one down there is not turned on because of the overcurrent or the short circuit, it means that you will still need to sort that one out. Having connected it, we want to test at the input, what do we have with the test on voltage. We have, what is that, Margaret?
To the 235 volts.
Yes, 235, that is AC. On the output, as long as it is off, we are still getting zero.
Okay.
Now, assuming that this DPMCB, double pole miniature circuit breaker, had an issue and it was allowing some voltages through, we would be getting some figures here, some values here. So now that tells us that indeed it is not bad at all in that scope of measurement. But again, the customer still alleges that there was dimming of light. So that one still indicates that in the event that loads are connected, this one misbehaves. It cannot stand the loads that have been connected. Now we want to turn it off and test at the output. Do we get voltage? Really? Now that is the next procedure, to turn it on and test the voltage at this point, ensuring that our neutral is well isolated and the, the MCBs are turned off. Margaret, take us through that procedure. To turn the DP MCB on, and then simply test the voltage output. Yes, I appreciate the fact that you are cautious. That is super, super amazing. So it is on, turned on by our top boss Margaret. So the next procedure,
to test for the voltage.
the output, right?
Output, yes.
Now ensure that the multimeter is still at AC 750. Awesome. Right. So let us go. We get the value 233. Nice. So we can tell at least that double pole MCB is still giving us an output. That is incredible. Now what we need to do is to then turn it off like that, and then after turning it off, now isolate the neutral. So you remove the neutral, and now when you unscrew it, you make sure that you hold it above there, above there, and just be slow. And then when you remove it, make sure that it does not go on the red side, because I'm ready with the stool like that. Some stretch it, and then you tape it. Now holding it without releasing it, because it might slide and be in contact with the line. That is good. That is some good work, Margaret. Yes. At this point, you need to take your time and ensure that you are cautious, so that first, if there is some current on the neutral, you don't get electrocuted. And if you were to leave it to slide, it does not get all the way to the line or the live. Yeah. Sorry about that. We needed to have something to cut it.
Yeah.
So have you confirmed that it is properly insulated?
Perfect.
Perfectly. Nice. Now that is at that position, turn it above right there. Ah, good. I love that. I love that. Now, the elephant in the room is definitely the line or the face. You can even, yeah, do like that. Yeah, it is okay. Now we have the live. Let me just show our top bosses the live. I've talked about the elephant being in the room. It's not as big as an elephant, but you understand my top bosses. So this is what we have using an uncontact tester magnet.
Yes.
Kindly test whether indeed that is power is flowing through that cable, right? Very high, because indeed indicating that that is the one that we has current, right?
Yeah.
Using an uncontact, sorry, using a contact one, just to be sure. That one, correct. So top bosses, I don't know whether you can see it is actually live. Now, what you need to do, Margaret, for that scenario is to be cautious of the face. Now, here, there is something that is very, very important. Because you have the glove, you have to switch it.
Okay.
You're supposed to have two. Don't know where the other one is, but we're going to explain. So if you have that glove right there, you can hold the part that is insulated with the glove. The reason why that is because the insulation can be punctured. Okay. And so can have current. Right. So now what you need to do is to take your pliers and then hold that cable.
Should they remove this one?
Yeah, sure, sure. So that you can get enough space.
Yeah.
All right. Just a second. Let me bring something for you.
Okay.
Hivi utafika bado?
Yeah.
Nice.
Tajaribu.
Nice.
Niko mrefu.
Now, the next. Oh,
Okay. Okay. I hope I'm not.
stable.
Yeah. Yeah. It's more stable.
Now, Margaret, tell us the next procedure now. I can see so many top bosses have joined the moment they have seen that it is Margaret. You top bosses, you don't like to see me. All right, I understand. Margaret, tell us now what next from there.
You're going to isolate the live.
Yes.
Yeah.
Isolate the light so that you can replace the DPMCB. Awesome. So the procedure is to use a pliers right there, and then ensure that you hold the cable first before you can start, and then ensure that the pliers is also not in contact with the meter board. Sorry, with the consumer unit because it is metallic, right?
Okay.
So just hold it a little bit and then unscrew it. Awesome. So you carefully lift it, making sure it is not in contact with the consumer unit, especially the metallic side, and also that neutral cable that we have. Once you do that, just careful, careful, good job, good job. Now from there, what you need to do is to simply take your insulation tape and then screw it as you hold with the pliers, right?
Okay.
Yeah, because it is still live. If we test with our non-contact, we can tell that it is actually very high in current. If we test with our contact, it is actually high in current. But with the pliers, we are still safe, Margaret, isn't it? All right. Now using your insulation tape,
Mm-hmm.
tape it.
Okay.
So you stretch a bigger a chunk, then you do your thing without cutting it, without stripping it.
Okay.
Right. Sometimes even if you discover that it can hold in one place without moving, you can simply use the two hands to do something. Do you want to strip it or what?
No, I want to hold it, then
Careful.
maybe just. Mm.
Okay. Awesome. Again, you have to be very creative as Margaret is, using the available tools, available means to ensure that everything is well.
Okay.
Yes,
No.
you're good?
Yeah, yeah. Just anxious.
No worries. It is totally understandable. Again, be very, very keen. That is brilliant move. Yeah, you start with the insulation side, like that, and then you release the tape. So ensure
I
that
cannot.
you stretch it right so that it can be straight. But that is a brilliant way of doing things. But again, ensure that you don't puncture the insulation, right?
Okay.
Awesome, awesome. Good. Once you have it rolling now, you're good to go. Good to go. That is incredible. Good job, Margaret, ensuring that you isolate the live, spend your good time and your insulation on that part. Very, very dangerous. Electricity is dangerous, like we say. And for you to carry out this work, you must ensure that you are licensed. Continue doing it until this space is not seen.
Oh.
You can't see anything right there. Continue doing it. Continue. Come this way front still until you don't get any.
Shock.
Yeah. Yeah. That's said and done. Now let us find a tool to cut it. You shouldn't remove it like that.
Okay.
Let me show you how to do it. So just hold it. All right, just a moment.
Okay.
This is an insulated whatever. What is it?
Serious.
Yes. So my top was to cut that insulation tape. Very important. If Margaret was to stretch it, it will definitely come off the work that we have done on it, isn't
Yep.
it? But now the good thing is that we have this pair of scissors. This pair of scissors is completely insulated, as you can see. All right.
Yeah.
So all we need to do is to use it and then cut that part. All right. So with the pliers, you can even release it.
Okay.
Yeah. Good job. Good job. Nice. So Margaret, this is what we
Can
have,
I
right? Uh-huh.
can I do that with the
You do
gloves?
it? Yeah, with the gloves, it's okay. As long as
Okay.
it is insulated,
Okay.
you're good to go. Yeah. Margaret is
Yes.
very cautious, and that is how engineers need to be.
Yeah.
We said safety first.
Yes.
Now, after doing that, Margaret, tell us if we have isolated that, Now, what is the next thing? Do we need to check on the visible signs for any damage on that MCB?
Yeah.
The best thing is to remove it completely,
Yeah.
right?
Yes.
All right, let's go ahead. What is the rating of that double pole MCB?
This one.
Yeah.
C63.
Awesome.
Yeah.
So that means it can only allow 63 and below to pass through it. Right. Nice. Now there is a part that connects from this MCB to this part here. Why is that? What is the purpose of that metallic rod?
This one.
Yes.
To look the neutral.
The MCBs.
The MCBs. Yes.
So it once the just hold it right there. So now once the live this line feeds it through this point here, and then it is on, it flows to this point, and then you can see it is connected to that bar. Right.
Yes.
So once it is on and current is flowing, so what would you say is the importance of that bar?
This one.
Yes, from the live of this DPMCB.
No idea.
Right. So the actual purpose is to connect the live that will be connected to this point and then supply that to the MCBs.
Okay.
Isn't it?
Yeah.
That's good. Thank you. Now, the neutral is supposed to have a bar right there. But where is the neutral connected, Margaret?
According to this consumer.
Yes.
Yeah.
Once the neutral comes from the DPMCB that we have removed, it is here, isn't it?
Yes.
And then it goes to feed at this point. Margaret can show you. Let me just get the camera closer. It feeds there, and that is where the circuits have been connected. That is not a good connection because it can lead to loose connection. It would better have a bar, a neutral bar, isn't it, Margaret?
Yes.
Loose connections in electrical connections are not good because they can lead to even sparks, isn't it? Yeah. All right. So now that we have that DPMCB, Margaret probably show us the one that we are replacing, the old one. Show it to us, the old one. Yes. So in most cases, you find that it might have some smell from inside. Is it having some funny smell, burning things?
Yes.
Yeah. So that indicates that indeed it was about to be blown, and that is the reason why the circuit was not completed, and it will actually started having issues with specific circuit. All right.
Yeah.
Okay. And somebody here is commenting this. Onyango has given some point. He's saying it is either you build a circuit or a timing bomb, and you know it is never good when Christmas comes early. He has also said, I only thought redundant checks are done in cockpit, but it is necessary in the electrical field engineering works. Absolutely. Now, that's good. Margaret,
Yes.
another thing that I would like to highlight on this is sometimes if there is a loose connection, you find that it is burning on this connection right here or the termination.
Yeah.
So you find that if, for instance, the cable was connected here, could be the neutral especially, because we see that our live was connected here. You find that once the loose connection is here, it starts burning at this point. Or at the output where we have the, you can see even that termination is turning to from copperish to brownish. Yeah, or to something that is rusting. So that indicates it was strained because of a loose connection, right? Another thing, you could also experience it at the line or the face. Yeah. Another thing that can contribute to burning or underperformance of this DPMCB is definitely aging. So assuming that it has been here used by this customer for a while and it has an issue, or it has been here for quite some time, then that definitely may mean that it is time for its replacement, isn't it?
Yeah.
So aging can be a factor, loose connection can be a factor. Another thing is manufacturing defects, all right?
Yes.
That is why it has to be replaced. And also if the customer has upgraded the electrical usage, whereby you find that at the point of installation they didn't have a pump, and then they used this C63, meaning it can only allow 63 amperes max, and they have upgraded, whereby at some instance you find that the total load that is drawn through it is actually 80 amperes. So you can also have a 90 or 100 ampere MCB, right? So Margaret, we want to replace it, and what do we have for us as a replacement? Wow, nice. So why did you advise the customer to use this brand? Why this one? Is it a quality one?
Yeah.
What other feature do you know about it?
It's a double pull.
It's a double port. Nice.
Yeah.
And another important thing is on the current that it allows as well. You have replaced it with a 63.
Yeah.
And I think that is a good one because there's no bigger load than that in this house, even if they were to be connected, all of them, right?
Yeah.
Yes. So
Yeah.
when it comes to that now, the procedure will now to start where we uh, where we connect the output. So the neutral, you start with the neutral to the output. So you start with the less dangerous connection to the more dangerous one.
Okay.
So we start with the neutral,
Yep.
the output, right? Awesome. Good job, Margaret. Top bosses, share your love, share your comments. If at all you think that this is a very good procedure that we are carrying out here with our top boss, Margaret, let us know in the comment section. If you think that there is improvements that require to be done, let us know. In our part 2 of this video, we shall be highlighting more of safety precautions. We shall be highlighting more of anything that you look forward to in case there is a mistake. Assuming that we make a mistake and then there is a spark, what are some of the precautions that we need to take to avoid that issue? So shall be talking about that as well, right? And my top bosses, if you're finding value already out of our today's stream, kindly smash that like button. And also, if you'll be watching it as a repeated version, let us know in the comment section where you are watching from, and in your country, what are the MCB, double pole MCB size that you use right there. We have a 63 here, sometimes can be, 100 amperes MCB. That means it can only allow 100 or less amperes in terms of current to flow through it. Remember, a double pole MCB protects against high short or heavy short circuits, but the primary purpose is to protect against an overcurrent. So an overcurrent in this sense, if it exceeds its rating, let's say it is exceeds a 63 ampere current drawn, it will definitely shut down to protect the circuit. Another important thing is ensuring that current above that. I mean, another important thing is to ensure that in case there is need to switch it off because of an emergency, then it means that it is easier to do that by manually switching it off. That is why it is also referred to as an isolator in other countries. Thank you. Thank you so much, my top bosses. I can see your response here. Ahmed Isaac says, thank you for this, sir. I am an electrical and electronics student in Northeastern National Polytechnic, Diploma Module 3. You are doing a good job. Thank you. Thank you, Ahmed Isaac. Special thanks to our today's top boss, Margaret, who is taking us through. Nice.
Yes.
Margaret, how is the experience so far?
Fantastic.
So explain to us what you're doing right there.
I want to connect the neutral
Yes.
back to the double port
Yes. And that is the output or the input.
output.
Nice. Good
Yes.
job. So we can see that you have done a very good stripping right there. Why is it important to ensure that you strip the insulation before you can tighten?
To ensure the connection is safe, more safe.
Yes,
Yep.
nice. So in terms of electrical and mechanical uh, integrity, we ensure that it is well done, right?
Yeah.
Nice, good job. So tightening it ensures that it is mechanically sound, like we usually say. It has to be electrically sound and mechanically sound. Incredible.
Yeah.
Yeah. So it is tight.
Yeah.
Also, yeah. And you have also ensured that it doesn't come out. That's good, Margaret.
Can't.
That's good. That's good. All right. And also, have you ensured that
Yes.
the bar that is serving the circuit is tightly done?
Perfect.
All
It's
right.
tight.
Nice. Good job.
Mm.
Now, the next thing that is very important is to activate that and use your multimeter and test for the continuity.
Okay.
I know we should have done that before replacing it, but behind the scenes, off camera, we ensured that indeed our double pole is working properly. So Margaret will at least attach it somewhere so that our top bosses can see as we do it. So carry the procedure, testing whether once we connect the incoming, because we have connected the outgoing, we connect the incoming, whether it will actually turn on. Yeah, that's a good position where people can actually see. Nice. It's on. Now
It's visible.
using your probes
Yeah.
at the input and output. Correct. So there is a continuity.
Yeah.
And
Yes.
if you turn it off and test also the line.
Oh,
It's okay. It's okay. So it is open
it is
when
open.
you switch it off,
Oh,
right?
yeah.
Meaning it will not allow current to flow.
Mm.
Nice. All right. Next process.
Mm-hmm. Um, we connect the neutral
Yes.
incoming
Yeah. Good.
inputs. I mean.
Yeah. That's all of those terms are acceptable. We connect the incoming neutral before we can go to the line. Now, my top boss on the chat, let me know why did Margaret suggest the neutral first? According to me, I know that that is the right procedure because in the absence of a neutral and the face is present and the load is connected, that can lead to what we refer to as a surge. So that is a good way of doing it, Margaret.
Okay.
Because that cable is longer, I think the
Mhm.
best thing you can do is to
Stretch it.
stretch it and then so that it can move away from your works as you are working over there. So you can even remove it from this part,
Okay.
remove it, pull it like this so that it can come out. Careful, careful, so that it does not touch the metal part,
Yeah.
like that. Yeah. Stretch it with the hand that has gloves, like that. Yeah. And then ensure that you bend it. You can even pass it over here. Great,
That.
great. Yes. Yeah.
Stay
That's,
away.
yeah. Stay away. I'm watching you. Right.
Yeah.
So now the next procedure, like you have told us, is to connect the neutral, right?
Mm.
Okay. given that we are not sure whether the neutral at times can have current, it is also good to be cautious.
Okay.
Yeah. So it suggests that you use a pliers to hold it, and then the hand, which has the glove, to be the one to remove the insulation, like that. So top bosses, why is it that sometimes the neutral can have current? What are some of the situations where the neutral can have current? Either you can use this contact tester and you discover that indeed the neutral has current in what we refer to as a floating neutral. That current is still dangerous, so you have to be cautious, just as our top boss Margaret is. Right. So does it have anything?
No, no.
Nothing, but you still have to be cautious.
Cautious.
So using your pliers, hold it in place, and ensure that you fold it so that it goes all the way up. Ah, good job. All the way up like that, and then connect it to. Did you ensure that you have unscrewed the screws?
Yes.
Good job. So when connecting it, ensure that you don't puncture the insulation, because that will compromise on the connection. Good job, Margaret. Yeah, so it's just about tightening it. Is it coming out or something?
Yeah.
Or is it the connection? The cable strip itself is too much.
It's too long.
Yeah, you can cut some parts because this is a different MCB that is prone to happen. You may find that the other one was a bit deeper. Careful, make sure that you don't injure your eyes. Once you press a lot of effort so that can be cut all of them, right?
Yeah.
At 52.42 minutes, top bosses that are here are 8 in number. We expect to have more when we will definitely release this stream as a video. My top bosses, I'm so grateful because of your likes, because of engaging in the chats. And if you'll be watching it as a recorded version, let us know on the comment section. What do you think about our today's procedure? Very important, especially in a life of an electrician, a beginner electrician, because in many cases you'll find that a customer will call you to operate on their circuits which are still on from the mains or from the meter box or the meter board. You must be very brave, just like our top boss Margaret is, to ensure that you work on the circuit as it's still on. Raymond says he's watching from Zambia. Margaret, you have a top boss all the way from Zambia watching you.
Wow. Thank you. Welcome.
Yes, awesome. Feel at home as Margaret has welcomed you. Incredible. Good job. Good job right there. Is it tight? Tightly held? Nice. And if you try to, twist it, it is locked in, right?
Yes.
Good job, Margaret. Now we go to the elephant in the room. Remember, our circuits are still off. And then I would request you, Margaret, to test whether they are tight as well.
Okay.
Yeah. So using a screwdriver, you can simply try to tighten and just confirm that everything is okay. You can judge this consumer unit as much as possible. It belongs to our client. So all we are doing is to improve on what we have here. But if we were to do it the top boss way, we would advise that we have a bigger, much bigger, almost 3 size of these that we have. Isn't it, Margaret?
Yes.
To accommodate other important devices, we have a very important device that should be here, Margaret,
Yeah.
which is
An RCCB.
correct. so that it can protect people against electric shocks. So that is what we would have advised our customer. So the next step, Margaret, the next step is the one that gives most electricians goosebumps, which is connecting the line, which is also not as sophisticated as people think. Simply ensure that first the screwdriver on that MCB is loose and ready to host the live conductor or the live wire. All right. Now, some of the safety precautions there are to ensure that that cable, while holding it, it is actually held by the hand with a glove. Number two is to ensure that you hold the end of the tape with the pliers as you undo the tape. And before you even did the tape, Margaret, it is always important to you ensure that it is a single tape that you have done, so that at the point where you are removing the insulation tape, it is simple for you to do it. All right, so we go ahead. That is a live line. Is it a live one? Can we confirm with people?
Oh, we should not test. Not a stool.
We have a stool ready here. The stool is ready so that in case Margaret has an issue of which we don't anticipate, we are ready to push her off using this stool. Yeah. So we are prepared here at Top Heights Electricals and Electricians. We are always cautious, but we don't definitely expect that mistake because our top boss Margaret here is very, very careful, as you can see. So ensure that you tightly hold that cable, remove the tape like that. Good. I love how keen you are, very careful, taking your time like that. Incredible. Now, the next procedure is to ensure that you stick with that cable still, and then taking your screwdriver like that. Remember, it is insulated. Show people. Someone was saying that our screwdriver is not. Look at that. Good job. Very much insulated. Now, you now redirect it all the way that DPNCB. Yeah. So slowly, you can also use your pliers, a pair of pliers, to hold it. And where you need to bend it, you can as well do that. So you can hold it like that. The other hand still holding that. Yeah. Yeah. So just take it all the way and make sure it does not touch the metallic part of the consumer unit. Good job. Okay, simply direct it all the way there. Go with it, go with it. Careful that you don't touch on the neutral.
That's right.
That's it.
Yeah.
That's good.
No.
It's a good sign that you're becoming a pro.
Okay.
All the way.
Wait. Okay.
Just slowly, gently, like that. You're almost there. Then simply insert inside like that. Good job, Margaret. Good job. Once it is there with your screwdriver, just pass it over to you. Sure that you hold it slowly, taking your time. Once it is completely tight, that is when you can release the pliers. Sure it is tight. Is it?
Perfect.
Good job, Margaret. And also, you want to use the
Oh.
sorry. That is what we refer to as phantom voltage. Something in your imagination happening that indeed there's a shock, but you're okay. Good job, Margaret. Now, let us use the digital multimeter to ensure that the voltage, incoming voltage is in. And also another procedure that we'll do is to carry out continuity test to ensure that once it is switched on, before we even switch it on, we will test that everything is okay. Somebody has said, Margaret, somebody has commented here, he is Elisha Ocheng, says, powerful, practical. Good job, Margaret.
Thank you.
They're impressed by your work.
Yeah,
Amazing.
yeah.
Now, Margaret, let
Yeah.
us test the incoming voltage on the screws of that double pole MCB. On the screws. Good job. Wow. 234.
Yeah.
Amazing. Now, let me just explain something a little bit there, Margaret. You see,
Okay.
the reason why we have tested on the screws is if on the screws we get an output, it means that indeed the screws are in contact with the wire itself. If it were in contact with the insulation of the wires, assuming you had done a bad job, it would have given us a very low voltage or even zeros.
Okay.
So that is a good job. But now before we activate the circuit, we want to know, once the voltage is flowing through these terminals, will the voltage be supplied to the respective MCBs, right?
Okay.
So now we place our multimeter selector to continuity. And then, good job. We then place the probe on the screw, on the output, on the output of the
Neutral.
Okay, the neutral, because it is sealed. This is a very bad connection. If we had a bar, a bar exposed like the one we have on the earthing, we would have done the procedure that you're about to do.
Okay.
But now that we don't have it is insulated, do that with the line on the output and then on the individual MCBs.
Okay.
Now, because you've connected them before we even switch them on, it will give us a continuity, right?
Yeah.
On the live,
Oh,
the output of the on the live output,
okay. Yeah.
right there, good. And then starting with the far end, good. That is what you get. The next second, good. The third, good. Elisha is saying hapo ndio sielewi kwa circuit breaker mtanisaidia aje hapo. Alright. You just watch the video from the start, you will understand. Yes. But I think if I understand Margaret, what he actually implies is for us to connect all the MCBs. Just a moment. Output. It feed all the MCBs. So I think that is what he's asking. Sorry about that. So the output has to supply power to all the MCBs, isn't it?
Yeah.
And we have checked that indeed it is supplying. If at all you don't get a continuity between these and these, it means that there is a loose connection, and most likely it is at this point, right?
Yeah.
Awesome. So we go on.
Yes.
So the next procedure is to definitely arrange our cables the best way we can. Remember, this is an entire house. Raymond is saying top boss include three-phase, practical as well. Awesome. We shall do that in due course, isn't it, Margaret?
Yeah.
All right. Now, what we need to do is to first ensure that we organize the cables. Remember my top bosses, if at all this connection was done in a correct manner using a bigger MCB, we would have fun at ensuring that all the cables are in line. So for that, Margaret, you would simply do what you're doing right. That, like they normally say, cheza kama wewe.
Cheza kama mimi.
Yes. As you're doing that, ensure that you don't puncture the insulation.
Okay.
Otherwise, you might have some challenges right there. So that is enough. That is the much we can do right now.
Yeah.
Now, for us to activate the circuit, the first thing that we need to do is to activate the MCBs
First.
right? Or is it the other way?
No.
We activate this and then activate. Yeah, actually, you activate the main
Mm-hmm.
and then you activate an MCB one by one, so that if at all there is a circuit with an issue,
Mm-hmm.
it will actually trip the respective MCB quick fast.
Okay.
So switch the main on. Careful, careful.
Yeah.
Good job, good
Pause.
job. And then the last one.
Start with this one.
Good job. Number 2. Good job. Number 3. Good job. Number 4. Good job. Awesome, awesome. I want to test whether the voltage is flowing through the circuit. What we need to do there, Margaret,
Mm-hmm.
is to test between the neutral, because we see that it is connected to that common point.
Yeah.
What we will do
Yes.
is to connect at this point here, the
Mhm.
neutral which is outgoing, and now it will not be on this point, but you can just test to prove that indeed there is an output.
Outputs.
Yeah,
Okay.
test. So first things first, where is the probe, is the multimeter on?
Oh. No, Baba.
Put it on.
Yeah.
Number 2, what are you
Mhm.
testing?
Voltage.
Voltage. Good. So it was at the continuity. If you would have tested at that, it would be problematic.
Yeah.
Bonkari says, what chose earth leakage? All right, let me just read it. He says, what
Causes.
causes earth leakage in electrical installation? I think the cause is usually a loose connection, or probably if there is a short circuit somewhere. All right.
Okay.
Yeah.
Now we test on the neutral, right?
The neutral and the the neutral and the bar.
Okay.
The neutral on the output,
Outputs.
yes, and also the bar. Let us see on. Good job. Now we want to test on the output so that we can be sure that all the MCBs are giving an output. So the neutral should remain there, and then the probe, the red probe, test it on the output above there of each MCB. Good. Nice. We have 230. Assuming that is the lighting circuit, we go to the second one. Assuming that is the sockets. Good. There's an output feeding the socket. The third one is probably the kitchen cooker.
Mm-hmm.
The kitchen cooker is activated.
Yes.
And the fourth but not the least, the last but not the least,
Yes.
is the shower circuit or a washing machine. It is on. Right?
Yes.
Good job. Good job.
Thank you.
Good job. Now, our top boss, Margaret, has successfully replaced a double pole MCB in a circuit that is live. All the safety measures were actually considered, but not all of them.
No.
We shall be talking about safety measures in such a procedure. But our customer has actually been done a very good job by
Yes.
replacing this DBMCB. You can see it is an old one. We assume that it actually failed due to wear and tear. Especially the problems to do with the neutral can lead to that. Now, Margaret,
Yes.
another thing that is very important is to ensure that you switch it off before you can replace the cover, so that in case there is a short circuit, you are not affected in any way, isn't it?
Okay.
Yeah. Good job. Now, only that one is enough, but to be extra cautious, that is okay. Now you need the cover, right?
Yes.
Nice. Are you ready with the screws?
Yes, I am.
Okay, fundi ni fundi, wanapenda kufanya hivyo, kujipinda wakati ambapo wanatafuta screws.
Fundi ni fundi.
Fundi ni fundi. Alafu sometimes atakuwa ameweka screw nyingine kwa meno na at the same time anaongea.
Na naitafuta.
Anaitafuta. Nilikuwa na hapo. Angalia kwa mfuko.
Kama umeweka kwa nywele ama kwa masikio.
Yeah. So the reason why it was important for you to switch it off is actually now at the point where you are closing that, yes, and you see that it might obstruct.
Yeah.
That you have to be very keen and ensure that you adjust it. Now, what you do, Margaret, there is to loosen this a little bit so that you can adjust it.
Okay.
Isn't it?
Yeah.
Let me hold them for you. Just a little bit. then you can bend it like that.
Then I tighten.
Yes. First, ensure that you press the screwdriver inside so that it
Okay.
does not roll on the screw. Itapoteza meno. Good. It is well held. All right. So again, this consumer unit is not a good one, and it is also not advisable because the ding rail was actually not aligned. Let me just check it once more. Another thing, when screwing, always ensure that you see cables such as this on the live cable. If, for instance, at this point where you are supposed to insert a screw and there's a cable, a red cable here, and then it is punctured, that means it will short circuit the cover, which is metallic, which is in touch with the earth connection, and the screw will be in touch with that live. That will lead to constant short circuiting and having issues for your customers, which they will again keep calling you back. So you have to ensure that that red cable is not on the way of that screw by simply ensuring that the cable is behind there, isn't it?
Yeah.
Now that we have done that, let us just ensure that there is some consistency here, because these cables are very strong. You know that, Margaret, because of their size. You could be pushing it this side. So simply do that, and then I think that is okay. Do you think there's anything you need to do?
No.
Okay, good. Right. So we go on. Next to move this side.
Yeah.
Let's again do it. So if it was us doing this job, we could have done it better. Or
Indeed.
you talk was if you were to install it from scratch, I believe you could have done a better job. Right. The main purpose of an MCB or a circuit breaker is to ensure that in case of a fault, it will trip. So let us start from up there, and then over here. All right. So this screw. Yeah.
What is screw? Nilikuwa nayo.
So having done that, my top bosses, our next video will definitely be to wire or to replace the MCBs or to add an RCCB to an existing circuit. Which one would you want my top boss for us to do? Or as our top boss had requested on the charts to carry out practical for three-phase, right? Raymond is asking, how do you bond your roof to earth? You earth it separately or you do what you refer to as grounding. And what roof are you referring to? So Raymond, thank you so much for being proactive on the chat. And I will appreciate your likes, my top bosses. If you're finding value out of our today's stream, smash that like button. And if you have not subscribed to our YouTube channel, which is Top Heights Electricians PLC, kindly subscribe so that you don't miss these upcoming streams. Which face did you use there, teacher? What is coming in here could be red, yellow, or blue. We are not so sure from the main switch down there. Right, incredible. Having some issues right there. Good job, good job. Then insert it. Try turn it. Good. Incredible. And the other screw is locked. Okay. press it inside. Is it holding?
No, it's
No,
so
it is okay.
yeah.
Right, awesome. Uh, Top boss Margaret has done a good job, and Evans has commented here. Evans Makori is saying, "Great job! I'm slowly becoming an electrician, though I just had a good grade in high school, and
Mm.
in high school physics 26 years back. Wow,
What
nice, nice. He's a legend. We appreciate
in the
your.
making?
He's a legend. Thank you so much. All right. So now we have done it, and now top boss, it is time to switch everything on and confirm with our customer that is indeed everything is working. Yeah. So start with the main, yeah, then go to the other MCBs. Good, good, good. You can test even the lights, bulb,
Mm. It's
test it,
working.
switch it on. Good job, nice. And then we can test also the socket that is right there, and then test whether our customer's microwave is on. We have placed tools on the microwave. We hope the customer forgives us. All right.
Yes.
So the light is on, the sockets are working, and other areas are also working. Raymond is saying this, Margaret.
Yes.
Good job, though. Poor
Thank you.
wiring in the DB board top boss.
Yes.
And we agree with that.
My customer will have to buy
Yes,
another one.
the customer will have to replace it so that they can actually have a better one, a bigger one, and a better one.
Yes.
My top boss, Margaret,
Yes.
how was the experience?
It was very educative.
Yes,
I've never worked on a live.
on a live
Yeah,
circuit.
thank you.
Awesome. Now, when it comes to the precautions, especially working on a live circuit, what would you say you would do it differently next time?
Next time.
Mm.
Um, observe safety.
Yeah.
Yeah.
Safety comes first
First,
indeed.
I had one glove on.
Yes.
Mm.
Good, good. So for us as electricians, it is always good to keep improving.
Yeah.
Even if today you may have something that is less than what you need to do, always challenge yourself to be a better version of yourself. Our today's stream was actually to perform an electrical work on a live circuit. How do you do that? We have started with a single phase. In what scenario will you have that? And we explained that in fact there are cases whereby you find that this customer is connected to a meter which is in the meter board that is locked, or the electrician from outside there, which is usually the case, does not have access or is not granted access to the meter board to switch it off, or the person responsible or the one that has the key, for instance, in our case, the caretaker, is not around or within, but this is an emergency issue, and you have to replace this important electrical device, which is a double pole MCB. So that is how you can operate